Hello everybody, my name is Jim Smith. I am one of the lead architects for the development architects for the Spectrum Protect portfolio, focusing in on Spectrum Protect Plus and data protection around virtual and physical environments. So let's dive into the presentation. We're going to talk a little bit, start by talking about why you're doing this. What are the advantages of taking backups at a virtual machine level as opposed to doing traditional in-guest file backups? It seems odd that we would still be talking about that, but there are a lot of people that are still doing in-guest backups for whatever reason, and they might have very valid reasons, but let's talk about the advantages of doing virtual machine backups. Then let's talk about the kind of meat of the presentation, planning the backup strategy. How do I approach protecting vSphere deployments? We'll talk about the fact that in a lot of environments we see a global set of policies that need to be applied to a majority, 95%, 98% of the virtual machine estate. But then the difficulty becomes in managing those exceptions. What do we do about those things that for whatever reason fall outside of the normal backup policy? We'll talk about managing that. We'll talk a little bit about optimizing the deployment, configuring and tuning the VADP proxies. And bonus material, we'll talk about how incremental forever backup works in Spectrum Protect Plus. Not necessarily something that's you need to understand, but I found in speaking to people about incremental forever that there's always a lot of questions about, well, how is this really working? How do I trust this? What does that mean from the back end? Is it as good as it sounds? So we'll be looking under the hood to answer those questions, so to speak. So let's talk about the advantage of virtual machine backups. So first off, on the left side, you can see we have the diagram, typical diagram that we'll find representing our Spectrum Protect Plus ecosystem. Not going to spend a lot of time on talking about this, but assuming that you understand coming into this the role of the Spectrum Protect Plus server, which is essentially the catalog or the database component. You understand the role of the Snap Server, which is the backup storage, and how the VADP Proxy, which is the data mover, so to speak, or the code that understands how to move data between data stores, and the Snap Server, the backup repository. And of course, we have our protected ecosystem, our estate here, the vSphere ecosystem. We have vCenter, and more importantly, we have all this storage that we need to protect. But what we will talk about are some of the use cases. So the first obvious use case is doing a recovery. If I have managed to back up an entire virtual machine, so that means that I've backed up all the disks, the virtual disks on that virtual machine and the VM configuration file, then obviously I can, if I know how to back those up, I probably know how to restore those. So there's this concept of production recovery, which is just simply restoring a virtual machine that's been lost. There might be cases where you want to make a clone, which is essentially restoring a virtual machine back to the data store, but you already have the production virtual machine running and you want to clone it, you want another copy of it, and maybe you want to customize that network setting so it doesn't cause any conflicts on the network. You can also do that with Spectrum Protect Plus. Both production and clone restores are essentially the same operation. We are either directly restoring blocks back to the data store, or we're using storage vMotion. Not going to get into the nuances or the differences there. To put a virtual machine back, the distinction is that the clone is going to assign a new GUID, so it's going to look as if it were a new machine in vCenter. The next really interesting use case is doing a test recovery, and this is what we in Spectrum Protect Plus sometimes refer to as reuse. But essentially, the idea here is we have a backup of a virtual machine from 7 days ago or from a day ago. We're going to instantiate that virtual machine, so create an instance of that virtual machine in vCenter and actually execute that virtual machine. The distinction is we're not going to move any data back to run this virtual machine. We're going to run the virtual machine from the disks as they're connected to the backup storage. So right out of that vSnap server, we're going to execute this virtual machine. You can do this in a fenced network environment if you want. The key here is those we're not moving data. This is very interesting because it gets us into some use cases where you can test a backup. For example, you want to know if your backup or your replicated copy of the backup is good. What better way than to make sure that you can use that backup to instantiate a virtual machine and boot the operating system and run some tests. You also see that if you have a copy of a virtual machine, that it's like any other virtual machine, and you can start doing things like logging into the virtual machine and finding individual files and restoring them. So that's another very interesting use case for what we call data reuse. Another very interesting use case is recovering single files, multiple files, single directories. So cases where you don't want to restore the entire machine, you might have just lost a virtual machine. Now, I spoke to you of one way to do it, which is to instantiate that virtual machine from the storage and just run it, and then you now have a networking problem to solve. Basically, you have to figure out how to get files off that machine, or you can just tell Spectrum Protect Plus to restore files directly, and we'll take a look at an example of that. Spectrum Protect Plus does provide an optional indexing option, so it will catalog all the contents within a backup, and then you'll be able to search the Spectrum Protect Plus server database for the file that you're interested in and recover a file directly. And this is a global catalog, so you could actually search for files across several virtual machines that have been backed up. The other advantage of virtual machine protection is that you have this concept of automatically discovery. So that simply means that we can register a vCenter with Spectrum Protect Plus, and we can create policies that say back up all virtual machines in this vCenter, and as new virtual machines come into existence, then they're automatically backed up. You can contrast this to traditional agent-based software where you have to go actually deploy an agent, either yourself or tell the software to deploy it for you on the machine before you can take a backup. So let's talk about planning a backup strategy for VMware vSphere. So this is a sample environment, and this is one that we used when we did studies on these types of questions about how does one go about managing data protection in these environments. So this is something we found as a fairly typical example. We have 600 VMs essentially broken across 4 clusters here, I guess, and each cluster has 3 hosts, 3 ESXi hosts, and we have a variety of different virtual machines, file servers, we have some Exchange and SQL, we have some SAP, again, Windows and Linux machines, etc. And this is the virtual administrator perspective. This is how the virtual infrastructure, whose job it is day to day to create virtual machines, to assign storage to virtual machines, views this. This is very different than how the backup administrator views this, because the backup administrator takes a look at that and he's immediately thinking about what he does and doesn't have to back up and how he goes about that backup. So, for instance, the backup administrator might look at this and say, well, these SAP systems and maybe one of these SQL systems, I've been told not to back these up, or the user isn't paying for that service, or we have another method. I can't convince the SAP DBAs to use this particular backup method. They have old tried and true backup methods. They're going to do it their way. So that's fine. I need to somehow exclude those virtual machines from my backup policies. I might have a standard, we look over here, I might have a standard backup policy in the organization that says I need to keep everything for 30 days, and we have a directive from an executive that says, well, we have a very important file server and we need to keep that data for 90 days. I might have SQL machines. Again, I have got an ornery DBA that tells me that I'm going to export and basically do a dump and sweep of my SQL databases. I don't want you touching my database or my logs, but of course, if my machine dies because of a patch I put on, I need a recovery of that machine. So we might be in situations where we only might want to protect part of the virtual machine, or in this simple example, only the virtual disk that contains the operating system and not the virtual disks that contain the SQL databases and logs. So if this looks familiar to you, I will tell you that this is evidenced at almost every customer that we talk to. There's a very interesting distinction between the virtual infrastructure administrator's view of this and the backup administrator's view. We found very frequently, and I mentioned this up front, that the organization will have a somewhat global policy or a very small set of policies. So backup every day for 30 days or backup for 30 days in 15 days. A very finite set of different policies, but they have a lot of exceptions they have to manage, whether it's virtual machines that don't need to be backed up or partially need to be backed up, or virtual machines that have special policy requirements. So let's talk about how we go and solve this with Spectrum Protect Plus, how we design a solution. So we have to first understand our basic requirements for data protection, the 3-2-1 rule, which says we're going to keep 3 copies of data, and we're going to do this in 2 different locations, and one of those is going to be off-site. And you need to have that exercise with how are you going to not only ingest data, but how are you going to replicate data and copy data off-site. You're going to then use the Spectrum Protect blueprints to determine the sizing for your environment. That is, how many of these storage components, Snap servers and VADP proxies, do I need to protect my environment? And this is going to be based on the front-end amount of storage you're trying to manage. So in the blueprints, we have a nice example where we walk through with a 100 terabyte example that we're trying to, of a vSphere state that we're trying to protect with replication, with copy and object store, and it walks you through how you size this. And then you're going to have to go through steps to deploy the infrastructure, the Plus server, the vSnap server repositories, the additional VADP proxies. And then this is where we're going to get into the presentation. We're going to assume that you're going to take care of steps 1, 2, 3, but we're really going to concentrate on these bullets: registering the vCenter, processing, getting the inventory, and creating the SLA and assigning workloads to this SLA. So we're going to be looking specifically at, again, registering the vCenter, creating the SLA, and we're going to approach it just like we approached that view of the last slide I put up. We're going to think about creating a generic policy that's going to protect a vast majority of our estate, and we might be doing that at a data center or host cluster level. And then we're going to talk about how to manage those exceptions, how to create exclusion rules, how to fine-tune virtual machine selection through the policy. And then we're going to talk about configuring the VADP proxy. So the first thing we need to do is we need to register a vCenter. And this is simply, you're basically instructing Spectrum Protect Plus or showing it your vCenter inventory. All you're going to do to register is you're providing an endpoint, which is an IP address, to your vCenter, and you're providing credentials to that vCenter. And there's a lot of information in the documentation about the privileges that those credentials need in order to not only take inventory, but execute backup and recovery operations. And then once you do that, Spectrum Protect Plus is going to run an inventory. And these inventories happen after you register. It's going to happen on a regular scheduled basis. It's also going to happen before a backup operation. And that's basically going to take the inventory from vCenter and load that into Spectrum Protect Plus. So if you have SLAs that say, I need to back up everything in this data center, then obviously the inventory process is going to go and inventory those VMs that are candidates that belong to that data center. After you do that, you can see here we have, I'm in the Spectrum Protect Plus user interface. I'm under the backup tab, and this is an old screenshot. There's no longer the restore tab, but it's the same. It will serve for the purposes of this discussion. I'm looking at a specific vCenter. This is vCenter 2012, and you can see I have several data centers, and what I'm going to do is I'm going to assign this data center to an SLA policy. So I'm creating this global policy that I'm going to use for a vast majority, 98% of my virtual machine workload. So that's easy. Basically, at this point, if all I needed to do, if I was thinking from the virtual infrastructure admin's point of view, and I had those 600 VMs in this one data center, I've basically created a policy that says at 10 o'clock tonight, I need you to back up all the virtual machines, all 600 virtual machines in this data center, and keep that data for 30 days and replicate it or whatever else that policy says. And in addition, any new virtual machines that are introduced into this data center, we're going to go ahead and back those up. We would be done at this point if it was as simple as that. But remember, that was the virtual infrastructure admin's view. We're dealing with reality. And so we're going to go and we need to start managing these exceptions. The most obvious way to manage exceptions is through exclusion. And this is not a new concept. We saw that one of the simple, when we're talking about file system data protection with the Spectrum Protector TSM backup archive client, your first defense against policy management was an exclude list. So not backing up, i.e. not backing up those machines that are not important. So one of the things that you will be able to do is exclude all virtual machines with a certain string in the name. For example, test. So any machine that has the word test in the name of the virtual machine or in the display name, we won't back up. So if you have an environment where you have some sort of standardized naming that you can exploit this to some level, then this is a very easy way to exclude resources. So the way I did this is I'm looking at my policy. Maybe I selected the gold policy, and over here on the right there's this little icon that says policy options that pops up this window. And in this window I can tell it to exclude these resources. And when your backup runs, you'll see a message in the job log that says, hey, I found machines test 01, test 02, test 03 that have been excluded, and therefore I'm not going to back them up. So when you're running the policy, just a quick note about executing the SLA. When you execute the SLA, by default, you can back up all the VMs in that SLA. So if by default we're backing up 600 virtual machines in this policy, and if I run this particular job that's associated with this policy, then all 600 machines will be backed up. There's going to be instances where you only want to back up a single or maybe a few finite set of virtual machines. This is called an ad hoc backup, so you can certainly do that. And the other very interesting SLA execution choice is rerunning only failed jobs. So let's say that you come in the next morning, you saw that your job that was to back up 600 virtual machines has executed, but 4 of those virtual machines failed. It's very easy to tell Spectrum Protect Plus, hey, please go rerun this SLA and only try to back up those 4 virtual machines that failed. That was exclusion at more of a global level, so we've taken care of machines that might have a common naming pattern. The next thing we might want to think about is individual policy exceptions for individual machines. So what we're going to do is we're going to go to our virtual machine in our inventory, this VM84Win, and we're going to go and click on select options over here. And this is basically going to select this virtual machine resource and hit the select options. And we're going to be confronted with a panel with a lot of options there's backup options, snapshot options, agent options, user SSH key options. So let's talk about these one at a time. Let's look at the snapshot options first. When we take a backup, we're going to take a snapshot of the virtual machine because we want the data to be in a consistent state when you recover the virtual machine. That involves some sort of filter in the file system or higher than the file system that's going to notify the file system and or the applications in the Windows case that a backup is going to take place. And again, this is to give us a file consistent or application consistent snapshot. Now there's 2 options here that you can see. Makes VM snapshot file consistent and fallback. So instead of telling you about what these boxes do, I'm going to tell you about the 3 use cases that you're going to find. The first is you might have a use case that says I need a consistent backup, meaning if it's not a consistent backup, to me it's not a backup, so please don't do that. So at all costs, make the VM snapshot file consistent, application consistent. We will retry. If we try to make a snapshot and it fails for some reason, we will retry to make a snapshot. But the point is, we're not going to fall back on an unquiesced snapshot if the quiesced snapshot or the consistent snapshot fails. And so what you want to do is you want to select this box for number one, select the top box, and unselect the fallback box. The second option is for those people that say, I need a backup. It doesn't matter. At the end of the day, I need a backup of the machine. And it would be nice if it was application consistent or file consistent, but it's not absolutely necessary. So I'm going to go ahead and for this case, I'm going to say, make the snapshot file system consistent, which allows it to try at least one time to make it file consistent. And if it can't do that, I'm going to check this second box that says, if I can't make the snapshot application consistent, then fall back to using unquiesced snapshot and just back up the data. Again, I need the backup. That's more important than worrying about whether it's consistent or not. And the third use case, which comes up every once in a while, you might have a SQL machine where you know you've had traditionally, even with other backup products or other backup techniques, had issues with, let's say, Microsoft Windows VSS infrastructure. You know that you're never going to get a consistent backup. So you want to instruct the system, don't even bother with trying to make a consistent snapshot. So you go ahead and uncheck this make VM snapshot application file consistent and leave this fallback with snapshot checked. So again, you have some snapshot options. You want to think about your use case. Are you I need a consistent backup administrator, or I just need a backup administrator? Or are you the all-knowing, I'm never going to get a consistent backup for this VM, don't bother. Okay, I talked to you a little bit about cataloging the file metadata or creating an index. And what this is going to do is we're going to create a global index of all the files that are on that virtual machine so that you can do a global search across the virtual machines that are indexed. And I'll show you an example of that in a second. After the backup operation is complete, i.e. the data is moved from the virtual machine or the data store into the vSnap repository, then we'll run a separate process that scans the files and directories on the operating system, basically bundles up the results, and sends that information to the Spectrum Protect Plus server, and then Spectrum Protect Plus puts that in a special catalog. And that, again, provides a global search for file entries across all virtual machines that have this enabled. You can recover individual files and directories from either the primary or the replicated repositories. You can't do this if you're copying data off to S3 object storage. And I said you're indexing all the files. There is also this catalog under the checkbox. There's this exclude file, so you can tell it, well, I know that anything in the program files side-by-side directory or Windows 32 directory, I'm never going to want a user to restore a file from there, so please don't bother cataloging those. So that's an option to you as well. There's a predefined set of excludes based on whether it's a Windows machine or a Linux machine. So this is the outcome. I can globally look for, let's say I want to look for a file with my name Smith in it. So I can go into the Spectrum Protect Plus user interface, do a search, and I can see that I've got these VIM files that appear, looks like, on a bunch of Linux machines, and you can see that they're on 3 different virtual machines, 192, 181, and 185 there. So I've now searched globally across all the virtual machines that are indexed, and I found 3 instances of files that look interesting. And what I can do there, if I decide that I want the files back from this 192 machine, then I can expand this selection, and it will show me that I have snapshots taken. You can see it looks like I was pretty aggressive with snapshots, but I took 2 backups on April 6th and 2 backups on April 7th. And I can restore, just check this, and I can click restore and restore that individual file to the virtual machine. Next, let's move into Microsoft SQL databases If you're backing up SQL databases, more than likely you're going to use the specialized Spectrum Protect Plus SQL support, which deploys quote-unquote agentless solution. So it will push code out onto the server, whether it's physical or virtual. You'll be able to take backups of not only the SQL database, you'll be able to port those backups, restore it to, let's say you back it up from a virtual machine, you could restore a SQL backup to a physical machine. You can also back up the logs, so you can get that 10-minute, 15-minute recovery point objective satisfied as well. Now that's for most SQL database instances, that's probably the path you're going to go down. But you might decide that, hey, I've got this virtual machine and there's a SQL server in it. And you know what? I don't need to have 15-minute, 10-minute recovery point objective. If we lose this virtual machine, it's okay to recover back to last night's backup copy. It's okay if I just have a consistent backup of this virtual machine, then that's good enough for this particular instance of SQL. The problem with doing this is that you can do this for a few days, but then you'll find that your log disk is filled up because nobody's clearing the logs. So that's what this checkbox is for. This is for, again, it's an option on your virtual machine backups. It's saying, hey, if there's a Microsoft SQL instance in this virtual machine, after you take a backup that's application consistent, after that data lands in the vSnap repositories, meaning you have a copy of the data safely stored outside of the virtual machine, then go ahead and truncate the SQL logs. And again, this is a very useful technique when you have a single database or instance on a VM. You don't have that 10-minute, 15-minute recovery point objective that you need to meet. You just want an application consistent backup and you want to manage those logs. This is a nice solution. I spoke a little bit about this use case. So usually a virtual machine has several hard disks. A lot of times they'll be provisioned in such a way that the first hard disk or hard disk 1 has the operating system. Hard disk 2, 3, 4 have all the application or development bits or production bits that are interesting to whoever's consuming that virtual machine. So there's usually two use cases that are prevalent. One is the user only wants to protect the VM operating environment. So that's basically saying my data on disks 2, 3, or 4, etc. is disposable, or I already have another solution. We talked about Spectrum Protect Plus protecting Microsoft SQL. For example, I have that solution, and that's basically protecting the data on hard disk 2 and hard disk 3. So I only want to protect hard disk 1 in this case. So that's one use case, and that's possible by selecting hard disk 1. The other is the opposite. It's basically saying I have a use case where my operating environment is not interesting to me. I'm building these off of clones and templates. It's not saving me any time to recover a virtual machine operating environment from a backup. I would rather just template and provision a new virtual machine. So don't bother with hard disk 1. But what I really need you to do is protect hard disk 2, 3, and 4. All the disks that have application data on it. Basically, by selecting either hard disk 1 or everything but hard disk 1, you can meet on an individual virtual machine basis, you can meet these requirements. So just real quick, some of the exceptions that we looked at, you can truncate, you can select individual disks for protection. We just talked about that. And then we talked about the two use cases. You can truncate SQL logs. You can enable file indexing. We talked about removing resources from the SLA, just not protecting the machine, or removing a set of resources by excluding. And we also looked at how to manage the snapshot and the quiescing and what happens if there are failures. That is one path. The next path is, and we were using basically in that path, we were using the vSphere, the vCenter inventory as it's presented to us, that very hierarchical inventory where we have host clusters made up of hosts which have virtual machines, and maybe there's some resource pools and intermix there. That's one path. The other path is with tags. And what we're going to do is exploit the fact that you can assign tags to virtual machines. And this also, the advantage of this particular method is that we're giving the virtual infrastructures admins a little bit of leeway to help dictate virtual machine protection through the use of tags. Meaning you might have a virtual infrastructure admin that says, I understand we've got to exclude certain virtual machines from backup, but I'm not comfortable outside of my vSphere web client. So unless you can provide me some way to do this through the vSphere web client, I'm not going to help. So using tags is a way to allow the virtual infrastructure admin to dictate that you don't want virtual machines to be backed up without that admin having to use or see the Spectrum Protect Plus UI. So basically what we're going to do is we can create an SLA for a group of virtual machines using VM tags or categories. So we can basically say, for example, we can set up an SLA that says any virtual machine that has this tag, SPP Backup Gold, I want to protect. And then the virtual infrastructure admin can simply assign this tag to the virtual machine that they want to protect through the vSphere web client. And so we can go in and we can just select this and we can select an SLA policy as we did in the last example. So that's tags. So let's move now into optimizing the deployment and configuration for the VADP proxies. The VADP proxy, this component, we talk a lot about the fact that Spectrum Protect Plus is agentless. So if we're doing a SQL backup, Oracle backup, you don't have to install any additional software. And that's true for almost every application except for VMware, because in VMware we're in this special situation where we can't push deployment of software onto an ESXi host. For these advanced data protection products or these modern data protection products, you need somewhere to run code that knows, again, how to talk to vCenter, how to talk to data stores, how to read and write data from data stores to make backup and recoveries. That's the job of the VADP proxy. And as you can see, it's an acronym for VMware Storage API for Data Protection. And you will always have at least one of these proxies for each one of your sites based on the sizing needs. And again, that's covered in the blueprints. So in general, if you have multiple locations, the first obvious recommendation is if you have multiple locations, if you might have a second location, another branch office, and you have backups that need to take place every night in both of the locations, you obviously want to have a VADP proxy that is localized, meaning you want to have a VADP proxy in location 1 in the primary site that handles the backup of all the VMs in this location, and you want to have a second VADP proxy in your second site, maybe in location 2, that handles the backup. Again, you don't want to be having the VADP proxy reaching across sites to pull data from a remote location into a vSnap server. At least you don't want that to be your plan A. So the vSnap server, we'll just talk a little bit about the relationship to the VADP and the vSnap server. The vSnap server is deployed either on a physical server or it's provided through an OVA. And you can push a VADP proxy onto any machine, any Linux machine that meets the operating system requirements. So the question becomes, why can't I just, hey, I've got the vSnap server there, why can't I just push the VADP proxy? We've actually updated the VADP proxy through the releases to actually ship on the vSnap server, and we'll talk about why you might want to exploit the fact that you have the VADP sitting on the same vSnap server. So we have talked about the fact that the vCenters must be registered and they'll be inventoried. Let's look at the data paths now and where the VADP proxy fits in. Again, I told you the VADP proxy's job is to marshal the data flow between the data store and the vSnap server. And there's two paths to that, two parts of that path. There's the transport, which basically deals with how the VADP proxy talks to the data store. And that's what we talk about. It's hot add, SAN, network-based, NBDSSL, for example. And then you have a path between the VADP proxy and the vSnap server, which is LAN-based. So there's no necessarily LAN-free path here between the VADP proxy and the vSnap server. we'll see that land free is kind of a misnomer in the next slide. But the point here is that the VADP proxy, if it's not on the same machine for whatever reason as the vSnap server, then when you're pulling data out through the VADP transport, you are writing that over LAN, so there's an extra LAN hop that you have to incur. Now, as I said, we can combine the VADP proxy on the vSnap server, and the advantage of this is that you still have the transport, you still have to pull the data from the data store through SAN, HOTAD, NBD, SSL. But the point is that now, since the VADP proxy is on the same machine as the vSnap server, then you've eliminated that LAN hop. There's no more LAN path. This is now writing to a local file system. Again, you're getting some performance benefits out of eliminating an NFS mount. So a couple tuning capabilities you have, and the objective here is you want to ensure that the VM backups don't overwhelm your available resources. So first thing you can do is you can limit the number of VMs processed from a single ESXi host at any one time. So you have the ability to say, I only want, from any host at any one time, I'm only backing up 3 virtual machines or 5 virtual machines. And then you can limit the amount of work that is being done by a single VADP proxy at any one time. So you're basically telling it, the VADP proxy, how many sessions, how many CPUs you want to dedicate to backing up data using the VADP proxy. The reason why this is important is if you're co-locating yourself on a vSnap server, you always want to guarantee that that vSnap server has enough resources, especially CPU in this case, to do its job. So you don't want the VADP proxy to overwhelm all the CPU resources. So basically we introduced this concept of a soft cap, which is basically going to throttle the CPU usage through controlling the number of processes that we spin up to do backups. And again, this soft cap setting is critical when the VADP proxy is co-located on the vSnap server. And there's a lot of information about this in the Spectrum Protect Plus blueprints. Now, real quick, if you look at the VADP proxy, you'll see that there's a number of options. The good news is most of these you don't have to worry about unless you're instructed by support to change them. But you want to make sure that the site assignment is correct, that you have a VADP proxy which you believe is backing up your primary or secondary site, that's got the correct assignment. You want to turn off transport modes that you know that you're not going to use, so they won't be, software won't try to select them. So if you're using a virtual proxy, VADP proxy, you can't use SAN. So just cross this off, eliminate this from the transport modes. The NBD SSL compression is optimization, and we only see benefits if you have slow networks, 1 gigabit networks. It actually slows down. It becomes a bottleneck if you have 10 gigabit or higher networks. And then again, a lot of these options you can set are going to be dictated through support. And then we talked about the soft cap task limit, which is really a way to throttle the CPU usage when you're co-located on a vSnap server. And this soft cap task limit will actually be part of the output when you run the Spectrum Protect Plus blueprints. It will tell you what to set that at for your vSnap VADP deployment. So real quick, let's get into some material here. And let's just talk about how incremental forever processing works. Again, this is not necessarily critical to best practices or deploying a solution in Spectrum Protect Plus, but it gives you some insight on how this process is working. And we get a lot of questions. Are you doing synthetic full backups? How are you presenting a full backup every day, etc.? So this should give you a little bit of insight into that question. So we have a virtual machine here, and I'll warn you that the first backup is pretty boring in these technologies. A full backup is not much because it's rather obvious. But we have a production machine, and it's got maybe six units allocated, 6 terabytes, 60 megabytes, 60 gigabytes, 250 gigabytes, 240, each one's 40. And half of those blocks are being used. We'll say 3 of those blocks are being used. So the first thing we're going to do when we protect this machine is we're going to take a snapshot. We talked a lot about the questing of that to make an application file consistent, or you might not choose to do that and just have it crash consistent. But we want to ensure that it's in some sort of consistent state for recovery. And we don't want these blocks to be changing underneath us as we're backing them up. And then what we do is basically we have a file system in our vSnap repository, the backup storage. We write directly on, we create VMDKs in the file system. So if you go and look at the backup storage, you'll see VMDKs that look like your actual VMDKs in production. And we'll write directly into the backup storage. So we'll write those three same blocks. So the file system represents the snapshot of that production system at that point. Now the next interesting thing we're going to do is we're going to take a snapshot within the vSnap repository. The vSnap repository is going to take a snapshot of the data as just written and call that T0. And it's going to basically saying, this is a snapshot of the blocks that I collected from my backup of my production VM at time T0. This is what it looks like, and it's going to record that. And this is a live file system, so you can continue to write onto that file system, write additional information, but we are safe knowing that if you ever want to revert back to this virtual machine snapshot to the time that you backed it up, we have a snapshot of that in our own backup storage. Now this is where it gets interesting. We make changes. We add a couple blocks, we change a block. So what we're going to do is we're going to use change block tracking that tells us these blocks have changed, and they also change block tracking in VMware also tells us that the location of the blocks have changed. And we're going to write those directly over. We know the blocks, we know the location. We'll write those directly over the file system on top. So now the file system looks exactly like what we have in production system. So we're not doing anything synthetically here. We're just simply writing over our copy of the data to make it look like what's in production. And then we're going to take a snapshot of that again. So now we have two snapshots, two software-based snapshots of our production virtual machine. Again, no synthetic full backups, no movement of data here. And we know that if we want to go back to point in time T1 or T0, the Spectrum Protect Plus catalog knows that this data is located on a specific volume in my backup storage, and it's associated with a particular snapshot. So if I wanted to go back to this point in time, the Spectrum Protect Plus catalog will instruct me, again, where the volume is, the data is under vSnap, and which snapshot to look at to pull back the image at this particular point in time. With that, we'll conclude, and I thank you. Thank you very much.